Hey, hello everyone. I'm Ashwin. I'm part of Wi-Fi TME team within Arista. Today I'm going to talk about a very interesting topic, exploring T2LM in Wi-Fi 7. T2LM is T2-Link Mapping. When both AP and a station supports T2LM, then we will get good practical benefits for admin. In today's session, we're gonna see for I think the ticker. Okay, so sorry about the glitch. This is the agenda of the day. What we are gonna quickly talk about is we will quickly recap MLO behavior. Then we will see what T2LM is, TID to link mapping, and how this map negotiation happens between the AP and a client. And then we will take a practical use case in a mixed world environment, or definitely Wi-Fi. MLO and non-MLO clients are going to coexist, and what is the current problem and how T2LM can help mitigate this problem. And I have defined three use cases for implementing it for the admin, given a fact that both AP and a client supports this, and a quick playbook from the admin standpoint. So from an MLO standpoint, STR MLMR, we already know like it's a concurrent operation. It gives us the aggregation benefit. And then we have another MLO modes, which is, I think you might need to put the lights. Yeah. So another practical mode is a EMLSR, which will give us the one is the aggregation benefit. STRS MLMR will give you the aggregation benefit, and EMLSR would give you the latency benefit. And then these are all the practical list of MLO modes available today. But out of all these modes, STR MLMR and EMLSR are the most practical solutions today. If you take a couple of clients, be it Google Pixel or iPhone, it's gonna support one of these modes of operation. Right. So quick overview on the packet level. What we see is the MLO. It's an association response frame. You would see the basic ML IE, which basically tells you these MLO is supported, and then along with that, this is the another IE T2-Link Mapping. This is what it defines the policy over the air. Right. So what is T2-Link mapping? There are two mapping available. One is a default mapping, which is as per standard, it is mandatory. Another mapping is a custom mapping. So let us go one by one. What in the default mapping, all ACs belongs to all links. That means any voice or video frame you're gonna transmit, it gonna go in both these links, right? But you don't have any customization of this. Whereas in the custom T2LM, you can actually do a sub. You can take some of these sub map these ACs into some links. Which means you can practically map voice video should go on 6 gigahertz link. You can do best effort background go to 5 gigahertz links. This kind of prioritization you can do. The advantage of doing this is you get a deterministic VAS. Right. So now that we have seen what T2LM is and things like that, the next thing is how this frame exchanges would happen, how this negotiation would happen, right? So there are two methods of negotiation is available as per the standard. One is negotiate via multi-link association request response frame. This would happen at the time of joining itself. And then another option is through the action frame. When we say at the time of join, what would happen is, let's take a case where a station wants to send an association frame. It can basically tell, I wanted to use best effort background in link 1 and then voice video in link 2, and I just simply wanted to disable link 3, right? So if AP accepts this negotiation, then it would accept, or otherwise it can just simply deny. When it denies, it just falls back to the default mapping. And this is at the time of association. There is another type of negotiation, which is at most of you can call it as a real time thing. Dynamically, AP and client can basically send this action frames. Think of a case where you already have a policy which is like best effort background, video, voice, everything is mapped to one link, and then you can send an action trigger to say, know you can have video and voice in another link and so on and so forth, right? So what are these benefits gonna help us in a very high level? Without this negotiation, without the client support, the negotiation is not possible, right? We want a proper client support so that the custom mapping is actually a possibility. So today, if you take Android 14 plus, you would basically see some kind of a support which we were able to validate in our labs too. Meaning, if AP today can send an action frame saying action frame to change channel or temporarily disable one or more links, then the station basically adheres to this action frame. That is very key. When it adheres, it basically don't reconnect the client. Without the client reconnection, it can dynamically change. So when it reconnects without these, what is so benefit out of this, right? Uh, let's take a practical case. In a mixed world, you would have Wi-Fi 7 and the non-MLO clients coexist. Imagine a case where Alex have a MLO client and then Bob have a non-MLO client. They are doing the Teams call, right? Everything goes well, the call goes fine. Suddenly there is a interference on the 5 gigahertz band. So what happens today is your non-MLO clients get stuck into the 5 gigahertz, whereas your MLO client sends this interference and then smartly move to the 6 gigahertz. That we have seen it in multiple places. When you make those calls, you would actually see. But this behavior is opportunistic behavior, right? Based on my first to free TX op, I just see this interference, this channel is bad, I just put it into the another channel, right? So this behavior is an opportunistic bad. But what is the problem with an opportunistic approach is if you take this example, and there is a high interference going on, and then all the TIDs are mapped to one particular band. So it's not only your voice and video moves to the 6 gigahertz band, but your bulk of background traffic too goes to the 6 gigahertz band. So what it means is everything moves to the 6 gigahertz band, and eventually it causes a kind of a congestion in that, and your call jitter basically deteriorates, right? So this is a practical problem, and to solve this problem is where the T2LM plays a vital role. Let's take the three practical use cases. The first use case is a baseline approach. Set the quiet lane at the time of join. The intent of this use case is to get the deterministic was. What it means is at the time of joining itself, an access point can have a policy that says, okay, for all the Zoom and voice call, Teams call, you keep those calls in the highest priority lane, right? Voice and video should go in 6 gigahertz link, and BE and background can go into at the time of the association itself. The advantage we get is when you make the calls, it will basically ensure that the voice and video will basically go in 6 gigahertz and keeping the bulk of background in 5. And eventually the non-MLO clients don't know where to go. But today we have a lot of techniques to for the non-MLO clients from an admin standpoint, right? We can see based on the lot of packet probes and everything, we can set a Slack message to an admin stating that there is a non-MLO client in that particular location is suffering, and then you should take some appropriate actions to move forward. So the second use case is more of a reactive case where you can flip the lanes based on the interference. The main intent of this use case is to keep the real time traffic clean even in a transient condition. So same scenario, let's take there is the call going on, suddenly there is a rising CCA or retries happening on 5 gigahertz. The trigger for that is the high retries. Then AP can immediately send an action frame saying, okay, you map voice and video to 6 gigahertz and keep your bulk of traffic in 2.4 or 5, right? And once the T2LM exchange is successful, then the policy gets updated. With this, right, the call quality will be maintained and there won't be any jitter because bulk of your best effort is going on the other lane. I think of the third use case is it's a more of an operational use case where the intent of this is during your the TFS hit and the CAC time and things like that, right? Your voice call would basically suffer. To mitigate that, the trigger for that is a DFS hit, and then you basically what you do is you temporarily move all your traffic, be it voice, video, best effort, background, to a clean link, which is 6 gigahertz, right? And then once your DFS recovers, once the channel is clean, then you move back to where it was, right? So it is kind of you pin these lanes to a kind of you can think of it as a maintenance phase. You temporarily move everything to a cleaner channel and then you bring back. So all these operations could be like dynamically operated. Um, and then moving on, how do we kind of do this packet level, right? What frames to look what and all, right? So you take a beacon packet. Inside the beacon packet, I just showed there is a multi-link IE. There is a link IE per station profile. Everything would be there. Your access point should definitely support T2LM for this to happen. And another important frames that you can watch out for is sufficient request response frame, where in the request it would basically tell you the tip mapping, right? At the time of association, you can map voice, video to 6, and all those definitions you would basically see. And couple of other things like cost data and management. These are some of the frames where you could actually see what the actual voice call is going, whether it gets prioritized, if it is prioritized, in what link it goes, right? A quick admin playbook where the reality check. The T2LM is optional as per the standard. We really want both API and a client supports this. You should treat it as a policy knob, not just a dependency factor. Um, so even if the custom mapping fails, it will fall back to the default mapping. Where it is really worth to be deployed, there are sites where you see a lot of mixed clients. You be it an MLO or a non-MLO client. If you see a mix of environment and you wanted to really prioritize the traffic, and that's the area where you can basically deploy this. And then what kind of policies you have? Uh, of course, the bare minimal easy policy is to basically pin voice video to a high priority line, which is 6 gigahertz, because usually 6 is free. Um, and then that is the simplest policy, but these policies are basically dynamic, right? You can think through various needs and wants of the customers and define your policy and then push it accordingly. And then you can apply some guardrails when you push them with certain condition. I don't want to simply push. I wanted to see based on some threshold hit, I will push it accordingly. And then how do you observe and adapt is basically you need to sniff the package over the air, understand your deployment, understand your client. If you have all newer clients or a mix of clients, that's where you basically can deploy the solution. And then, as I already mentioned, it's a fallback is always there, right? If the association fails, it will fall back to the default mapping, and you don't have anything to lose because default mapping is something which is mandatory as per the standard. Um, and most of the top client vendors like Android already supporting this. Um, yeah, so that's pretty much it. So just to conclude, Wi-Fi 7 gave us the multi-road. Think of this as a multi-road with MLO, and T2LM enable us to print these lane markings so that your high priority traffic such as voice, video, or maybe a Zoom call or MS Teams call basically take the high priority lane, keeping your other traffic in the low priority link. So with that, I conclude my presentation. Thanks for the opportunity given. Yeah.
Yeah. Thank you. Thank you. Time for QA session. Yeah. Wash.
So, Ashwin, this is this only the AP side telling the client start the mapping now? Can't the client initiate mapping rules? And two is on the downlink. Of course, mapping has always been a problem, right? In terms of knowing the traffic a little bit better compared to the client side. So, for example, will iOS obey any AP's sort of diktat on say now map this traffic, etc.?
Yeah, that's a good question. So today we are seeing this support from the Android. We indeed tested with iOS. We could not see that movement happening. But I presume over the period of time, things would get improved when this gets into the mainstream. The second question is for your second question is, this is a default mapping which is can be done on both the sides. Though my picture depict everything happening from the AP to the client side, because I'm basically from the AP side. So, but the same thing can happen from the client side too. The client can send action frame, and if AP supports the movement, then it would also adhere to the action frame. But those are certain things that we need to test today and see how much of this is quite possible. But one thing which I have tested in our lab is we kind of send the action frame, and we were able to disable the other link, which we think which is huge, because obviously when you are doing MLO in every other deployments, your 2.4 will always be congested, right? So today we can see these clients supports those action frame and take action in restricting data transfer in 2.4, keeping 5 active, and then it is vice versa. Without client disconnection, you could see the data traffic happening on both links.
What about if clients also use MSCS to tell the AP what traffic to map? Do you see that being conditional for this? And actually, iOS is mapping, by the way.
Yes, but we that is something which we need to check in these cases, because there is no it's pretty difficult to validate it, because there is no trigger factors from the station side. That's a problem. It's a generic problem as a vendor we have, right? At least on the AP side, we have a root shell and things like that. It's very easy to trigger it and see things are happening fine. But client side, of course, they are supporting, but we don't know in which condition it is getting supported at this point in time, unless we do a lot of testing around this to determine the end-to-end scenarios.